Okay, now let us see this one, which is joining a hinge and then the ladder or a rod. And from rod AB of mass 6 kilograms and length 3 meters is freely hinged at A, and the load of mass 2 kilograms attached at B. The rod is kept in equilibrium by a taut string CD of length 1.5 meters, which is attached to a point C on the rod and to a fixed point D on the same horizontal ground as A. Given that SC is 2 meters and AD is 2.5, find the tension in the string. So start with a simple sketch. Okay, we have our rod. Let's assume that our rod is going to be hinged at this point here. So let's assume that our point A is here. And then the appendix at this string is the same. This A, there is a string which is attached, which is fixed at the point B on the same horizontal level as A. So it means that now, that's how we by the way summarize the equation. So at A, at the same horizontal level, this is the same horizontal level, as you can see. And there, I'm going to be having where the string is going to be fixed. Let me call this D as it is in the question. And then telling us that AD is 2.5 meters. We are handling the question. We are now converting it into a diagram. Okay, so because there is a mass attached at this rod AB, it means it's not going to be horizontal. So we assume that our rod is going to be somewhere here. This is going to be our rod. Let me say this is going to be my rod. So this rod is B. A, B. Now the string is attached from B to a point here, which I don't know. A point I know which is C, but I don't know which angle. So they're telling us that a load of 2 kilograms is attached to B. So this is here I'm going to be having a load of 2 kilograms. So we are going to be having a load of 2 kilograms, which I'm going to say is going to act like that. Okay. The load is kept in the brain by the taut string CD. CD. So this is D, which is attached to a point C on the rod. So this is the point C on the rod. So this is CD. On the rod to a fixed point D. This is now a fixed point D, as you see, on the same horizontal level as A. Given that AC is 2 meters, so from here up to here, they are 2 meters. So I have this as 2 meters, meters, not centimeters. Given that AC is 2 meters, okay, and the AD is 2.5 meters. Then the string of length CD 1.5. They're telling us this is 1.5 meters. Okay. So I don't know this angle, I don't know this angle, and I don't know this angle. So let me call this one theta. Let me call this one beta, and let me call this one alpha. So we need to get this angle first here. Now, we start this one was a uniform rod, meaning the weight is going to act in the middle. So the whole rod was having 3 meters. So if this one is going to act in the middle, so this is my mid. Let me take this to be my midpoint where the weight of that rod is going to act. It was 6 kilograms, so the weight is going to be 6. The mass type is D. So it means that now from here up to here, it's going to be 1.5 meters. Then from here up to here, it's 2 meters. So meaning if this is 1.5, then this is going to be 0.5 meters. Simple as a add this, and this you get the 2. So if this is 0.5 meters, then this is going to be 1 meter. That's what is going to be our mass there. Because if this is 2, this is from here up to here is 2, then this is going to be 1. When you add it, you get to our sum. there. So basically, that's the diagram we have. Now, the question is, this plane is going to be a tension, but the question is in which direction this tension is going to be. Now, you see, this rod is trying to fall, so it means this plane is going to be having the force that is pulling it in that direction. So, these are now the tension is going to be in that direction. Now, because we have a hinge here, we expect a reaction from the hinge. So it means that we are going to resolve, of course, our reaction is going to be in this direction. So we shall resolve it. This is going to be our reaction, y, then the horizontal, which we are going to take in this order. Now, how do we determine the horizontal? Now, note from this, if I draw a parallel and points, it means that this one is going to be beta. So you see this one, if I resolve now this force, this is going to be adjacent, so this is going to be t cos beta adjacent, this would be t sine beta. How do I determine the horizontal at a hinge? The horizontal is always in the opposite direction to this tension, horizontal component of the tension. So you see the horizontal component of the tension is that side, so the horizontal component at the hinge is going to be in the other opposite direction. That's why it's going to be in this side. We're going to call it Rx. So our reaction is going to be there. Okay, so basically we are done with our question. So the question is, how are we going to handle the tension of the spring? Now, we need this angle here. Let us start by getting this angle here. That angle is going to be, we call it alpha. So if I have this side, I have this side, I have this side. So I need that angle. So we are going to use cosine rule. So using cosine rule, you see the opposite side is 2.5 squared. These two sides we have, this from here up to here is 2 squared plus from here up to here 1.5 minus 2 into 2, 1.5, then cos of this angle, alpha I'm looking for. So from there, you can able to see, when I simplify this, it's going to give me, okay, let me pause as I get the answer. Okay, when you simplify, this gives us this and this gives us this, and then this is going to be 3 times 2, which is 4. So it's that our cos alpha is 0, and cos of an angle to give you 0, our alpha is going to be 90 degrees. So means that this was a perpendicular. So we have alpha there. It means that now we are free to take anything. So if we have this now, it means that this angle, this triangle is going to be a right angled triangle. So this is now a right angled triangle. Now we know that. Okay. Now I want to get this tension in the string. What I'm going to do, I'm going to take moments at A. So taking moments at A. Why am I taking moments at A? Because I'm seeing there are many forces from A. I have this, then. So when I take moments at A, I can see that the only thing which is going to be surviving is this. And I have the perpendicular distance is going to be equal to the sum of the remaining. So taking moments at A, you see anti-clockwise in that direction. So anti-clockwise, I think you can see. So from here, you see this force T. It's going to act in the other direction like that. I think we can. So it's anti-clockwise. Then this one is going to be acting clockwise, and this one is going to be acting clockwise. So we shall use the principle of momentum. So now I'm going to be having this force T. Remember now this alpha is perpendicular. It's 90 degrees. So we have T, then times. Now the perpendicular distance from here up to here, it was 2. From here up to here, it's this 2. So it's going to be times 2 equaling 2. Now, if I turn now this, you see this one from A is going to act clockwise, I think you see. But I need this perpendicular distance from here up to this force. So allow me to this force here. So that's my force. Now I need this perpendicular distance. So I know from here up to here is 1.5. So if I draw that diagram there, I think you can see if this is the theta, it means that now I have this, I need this. So this is 1.5 meters. So it means that now this one is going to be, you see this is adjacent, so it's going to be 1.5 cos theta. So now I'm going to be having 6b times 1.5 cos theta, then plus. I have this one, 2b, I have 2b, then times. Now for 2b, I'm going to still draw a simple for 2b so that I can get the perpendicular distance. This is going to be theta now, but now from here up to here is 3 because it's the length of that rod. So meaning this is going to be 3, then cos theta. These are now this distance from here up to here. This is the perpendicular from where I'm taking moments from. So from here up to here, the perpendicular distance. Because these are vertical forces, their perpendicular distance will have to be horizontal. So this is vertical, horizontal is the perpendicular. Vertical, horizontal. So from here up to here, it's going to be 3 cos theta. But you can able to see that we can get the cos theta. So how? So you can see, I don't know, I can write, okay, this is going to give me 2t equaling d times 9.8 times 1.5 times. Now cos theta, you see this cos theta, I have now basing on this. Cos theta is given by adjacent over, I mean if I have this as my cos theta. You see I have the hypotenuse, I have the, you see I need the adjacent from here up to here. So if from here, let me show you there, a simple diagram there. Okay, I think you can see this diagram. If I get A, C, D, and I call it here, and I need that cos, I think there you can able to see because so that this angle is 90. So that's why my cos theta is going to be the adjacent over the hypotenuse. So that's why I'm having 2 over 2.5, then plus 2 times 9.8 times 3, then times still half cos theta adjacent over hypotenuse. 2 over 2.5. And from there, my t is going to be divided through by 2. Okay. You can just get 6 times 9.8 times 1.5 times 2 over 2.5 plus 2 times 9.8 times 3 times 2 over 2.5. The whole divided with this 2. And so from there, my t is going to be my calculator. I think you can see the answer I've got there. So my answer, the t is 58.8 newtons. So that's the tension in the string. Okay. So that is part A. They want us to get, this is part A. So now they want us to get the B, the magnitude and direction of the reaction at the hinge. So meaning you have to get x, Rx, and you get Ry. So it's all being horizontal. The moment they start, they are asking you to get the reaction at the hinge. You resolve vertically and horizontally. That's the idea. Simple. So my Rx, is that what is going in this direction? It's already this force. So I'm having T, this one in this direction, cos beta equaling 2. I think this is the horizontal force going in this direction, equaling 2 Rx. Now my T is 58.8 times. Now let us see cos beta. I mean beta. It's now that there. If I draw now another diagram from here, then I have this, then I have this here. I think this one was R90. So this is A, C, D. Now this is my beta here. You see beta from here to here is 1.5. Then this is 2.5 meters. Then this is going to be from here to here is 2 meters. So I can only get my cos beta. So my cos beta is given by adjacent, which is 1.5 over the hypotenuse, which is 2.5, and that will give me my Rx. So from there, my Rx is going to be so here I'm getting 35.28 newtons. So that's the horizontal reaction. If I want now the vertical, I resolve vertically. See, vertically we have Ry. Ry will be equaling to this one is also vertical plus T sine beta equaling to, now this one is acting downwards, we have 6G, then plus 2G. So that my Ry is going to be 8G, then minus T, which is 58.8, then times sine beta. Our sine beta, so it's that here I can get sine. Sine is opposite over hypotenuse, which is going to be 2. Okay, I don't know if people will be able to. Okay, let me take it slow. And I just put here sine beta. Sine beta. We are taking this inside. So our Ry is 8 times 9.8 minus 58.8 times our sine beta opposite over hypotenuse 2.5. So from there, my Ry is going to be now so here I'm getting 31.36 newtons. That's going to be my horizontal component and the reaction. Now, this is where our reaction was. So our reaction was having this and then this. So this is our horizontal component. This was our vertical component. Then our reaction was acting in that order. So this was our R. So the angle, then that's it, our angle here, theta. So that my R is going to be, you get the square of the x component plus the square of the y component. So my R will be 35.28 squared plus 31.36 the whole squared. So my R from there will be it's giving me 47.2031 newtons. That is my reaction. And after getting that, we come and we get our theta. Our theta, you see, it's going to be tan inverse. This is going to be the opposite if I do this. This is the opposite, which is Rx. 35.28 over the adjacent, which is Ry, 31.36. So our theta is going to be so here I'm getting 48.37 degrees. To the vertical. To the vertical. So that's the direction. And so we have finished that. So that's how we handle this number. The idea is whenever you go to learn how to squeeze out those diagrams. So the hinge direction, even if you take it this Rx in the wrong direction, here you will get a negative. The negative means you have to take the direction opposite. So don't mind about which to be right. So whenever I start, you are getting Ry or Rx as a negative. It means that the direction you took was supposed to be the opposite. Anyway, that's it. I wish you well.